Part 2 of this lecture discusses sedimentary rocks. First, we define them. Sedimentary rocks are rocks that form at or near Earth's surface as a result of a variety of mechanisms. One way that they form is through the compaction and cementation of loose fragments, known as clasts or grains, of other pre-existing rocks. Sedimentary rocks can form through the growth of shell masses or by the cementing together of shells and/or shell fragments. They can form through precipitation of minerals from a water solution. Sedimentary rocks can also form through the evaporation of water, resulting in mineral deposition. Finally, sedimentary rocks can form through deposition and compression of organic material. One example of this is coal. The first type of sedimentary rocks we'll discuss are clastic sedimentary rocks. We can really divide sedimentary rocks on the previous slide into clastic sedimentary rocks and chemical sedimentary rocks, with the first bullet being clastic and the 4 bullets occurring afterwards having some chemical process defining their formation. Clastic sedimentary rocks, conversely, form in a once separated grains that have been compacted and cemented together. The classic example of this shows weathering from outcrops at the surface, perhaps in a mountain range, that get broken down. They get eroded from that area of the mountain that they came off their rock and get transported through river systems all the way to beaches and deltas. And during this period of transport, the grains become more rounded and they also become more separated based on their density. So this figure explains that as the sediments are deposited out in the deltas and the oceans, we have coarser sediments near the shoreline and finer sediments getting deposited further out, because those finer sediments are lighter and they stay in the water suspended longer. Different types of clastic rocks are mainly distinguished based on their clast or grain size, but they can also be described using their composition, angularity, sorting, and maturity. The main types on this table 5.2 shown below of clastic rocks are shown. Conglomerate, sandstone, and shale or mudstone are the most common and easiest to define. Conglomerate consists of very coarse clasts. Think of boulders, cobbles, and pebbles all being a part of a rock as individual grains. Sandstone is purely made of sand, mostly quartz. And shale or mudstone is made purely of clay. As transportation occurs, these characteristics of the sediments change. So angularity decreases and sorting increases the further you get from the source of the material that was eroded, that was weathered and eroded, and the longer time you have been away from the event of weathering. This happens mostly by fluvial means or rivers, but can also happen through aeolian or wind. Mature sediment is more sorted and less angular and contains less clay. After these sediments are deposited in a certain environment, it's important that they get buried by other sediments and then lithified. Lithification is the process whereby sediments are changed to solid rock, and that's a result of increased heat and pressure as the rocks become buried deeper under other sediments. So here we have pictures of sediments and what these sediments would look like if they were immediately altered to sedimentary rock based on similar compositions. So the other ways that sedimentary rock can form are all through chemical processes, and these can be related to biology or life or not. One way to divide them up is into carbonates and evaporites, whereas the carbonates form from the precipitation of calcium carbonate in warm, shallow marine areas as a result of the death of carbonate-bearing organisms like corals or plankton or even mollusks. The second type are evaporites, and these form as a result of the evaporation of water after some mineral has been precipitated, for example, salt, or after some organic material has been deposited, like and preserved from decay, like wood and grasses and soil in swamps, which eventually form coal. Biochemical sedimentary rocks occur when organisms extract minerals from the solution to make the shells, which accumulate and lithify into rock. So limestone is the best example of this, where we've got shells that you would say on a beach or in the shallow water eventually get buried and lithified into a limestone. Biochemical chert forms similarly to limestone, except for the remains of the skeletal material are not calcium carbonate, but they are silica from plankton that accumulated on the seafloor. So some plankton have carbonate and some plankton have silica, and this produces, after death of many of them, different rock types. Organic sedimentary rocks, coal is the best example, where we have an ancient swamp environment where the organic carbon has been preserved and eventually buried and lithified to produce coal. Here are some pictures of evaporites. So evaporites form as bodies of water evaporate and dissolved minerals precipitate out. The best example is halite or table salt. Another example is gypsum used in drywall. There are some chemical sedimentary rocks that form through precipitation of minerals that aren't salts. These would be travertine or replacement chert. Travertine is crystalline calcite formed by the precipitation from groundwater. This can form in hot springs or in underground caves, which form speleothems. Replacement chert forms when silica precipitates from groundwater and replaces other minerals within a solid rock. So this occurs when bones or other materials fossilize, called perimineralization. This also occurs, the process that occurs to create geodes, which you may have seen in rock and mineral shops in nearby cities. Sedimentary structures form during or immediately after deposition, and there are various features that can form. These include bedding and stratification, structures due to moving air or water, graded bedding, and mud cracks. Bedding and stratification is the most common sedimentary structure seen because sedimentary rocks are deposited in horizontal layers. So as the source material changes for the sedimentary rocks, as we change grain size from coarse to fine, we have the production of bedding planes that separate the rocks into distinct layers. So this represents a change in source material, but also a change in conditions at that particular location. Ripple marks are examples of structures from moving air or water. So as sediment is deposited, the air flowing or water flowing above it creates some ripples, and these can be preserved as sediments lithify. So the ripples that you see on the beach in figure A that are created from the back and forth movement of wave water in the ocean can be preserved in the rocks as well, shown in figure B, if the area is buried very quickly. Dunes also form from moving air or water, but are much larger than ripple marks. So the process here is that the grains are carried by wind over the top of the dune, and then they fall or roll down the side of it. Over time, this creates different sets or different groups of dunes, and they can get preserved. Another structure from moving air or water is crossbeds. Crossbeds are laminations inclined at an angle to the top of the sediment layer in a dune. You can think of crossbeds really as the cross-section of dunes. So here we're seeing the crossbeds in the schematic and in a real-life photograph at a very large scale. Crossbeds are typified by a period of erosion or a planar surface that cuts off the bed and creates a new bed on top of it. So we call this truncation, and we know that this cutting off of the angular depositional features to a more horizontal depositional feature indicates some period of erosion and then new deposition afterwards. Graded bedding is the phenomena where a layer of sediment has grain size variation from coarse at the bottom to fine at the top in succession. Graded bedding occurs in turbidity currents as material flows down submarine canyons. You can imagine the coarse, dense, heavy material falling to the bottom of the canyon first, whereas the very light clay-like material stays suspended in the water column and takes a long time to fall down, settling last. Finally, we have mud cracks. When mud gets exposed to the air after deposition and dries out, it often leaves warped hexagonal plates, and this can be preserved as hardened mud lithifies if it is buried rapidly.